Hi. Okay, so we are going to be writing code today instead of just the usual what we've been doing until now, which is we've been talking about code. We're going to actually start writing it. This is going to be typical of my recorded lectures. So my recorded lectures are a lot shorter, as you'll be able to see by the video length. This is going to be a lot shorter than an average class, but it's going to be more densely packed with information, meaning I'm going to talk a little bit faster and there's a lot more stuff to cover, and I'm going to explain it hopefully completely but quickly. And so you're expected to come back to this 2 or 3 times. So, where do we begin? We begin by getting a program we begin by talking about the language we're going to code in, right? We are going to be programming Java. Java is a compiled language, which means that it actually, you actually compile a program. You can compile the program and then it runs on the JVM. So we're going to need to install Java. We're going to need to install something called the Java SDK, which is the Java Software Development Kit. And then we're going to start writing some basic code, and we'll talk about that code as we write. So, last week we already spoke quite a bit about Java. I'm going to fade over here. We're going to look up IntelliJ. We are going to use IntelliJ to run. We're going to use IntelliJ as going to be the program that we run our code with. So I'm not going to download the basic IntelliJ. I'm going to download the Community Edition. So we're going to go a little bit lower down. We're going to go to the download page. And now at the download page, there's Ultimate, and I don't want Ultimate. I want IntelliJ IDEA Community Edition. So I'm going to download this. I'm downloading for Windows. So I'm going to download the Windows version. If you are not on Windows, if you're on Mac, it'll offer you the Mac version. If you're on Linux, it should offer you a Linux version. So it's going to take a couple of minutes to download. In the meantime, while that's running, we're going to talk a little bit about, we're going to actually download, we have to go to Java, we're going to get the Java SDK. And Java downloads, right, from Oracle. Decline all. And we're going to get Java 20. For now, we're going to get Java 25, which the x86 compressed archive. This is what we would download. We're not actually going to download it. Instead, Java is created by Oracle, but when we use IntelliJ, you'll see that we're able to automatically download the Java SDK as part of creating our first project. And this is the cool thing about a well-made, or at least like a more robust, what's called IDE, which is Integrated Developer Environment, which is really all that code is. And the reality is that all that code is just a bunch of text, right? Code is a bunch of text that a computer understands well enough to be able to translate. But the reality is that when I write my code, all I'm really writing is I'm not writing code, I'm just writing some basic text. So I need to have a spell checker, right? The same way I would have code for spell checker, and I want to have an autocomplete, which would make typing it easier. And I want to have the translator for my code directly in the same program that I write it in. So all of those things where we use something called an IDE, which stands for Integrated Developer Format. What does that actually do? What that does is that allows us to have better access to our. It makes our jobs easier as programmers, is really what it does. It just makes it much simpler to just run the code and do the things we got to do. So you can see that the install file finished downloading, so we're going to run the install file. So I'm going to go whoop, and I'm going to open my .exe file. I'm going to get this please wait, validating setup, and then I have to authorize it as admin, and then I have to authorize it again as admin, and then, well, this actually opened twice, but I will close one and I will run the other. Okay, so IntelliJ Community Edition. Yes, I'm going to click next. I'll just install it in the, actually I need to, for now I'll install it in the default location for me. So create a desktop shortcut. We want to add it to the bin. This allows us to access things from command line. We want to add open folder as project to a context menu, and we want to create an association for Java and Gradle and Groovy, KT and KTS and POM. This is just saying, hey, this is just some basic stuff. I'm not going to explain too much in depth right there. Now we're going to install it and create our shortcuts in the menu, and now show details. And that's going to run the install process. So while it's installing, I'm going to go back to talking a little bit about what a IDE is. So an IDE is an integrated developer environment, so it has all those tools that we discussed. IntelliJ is a really, really great one. Even the Community Edition has a ton of features, and like the Ultimate Edition has like a bunch more features, and there's a lot of plugins for it. In general, we tend to use, like you'll see for a lot of your programming here, as you go through some of the, especially through the web development side, you'll notice that a lot of it is with Visual Studio Code. But we are using not just Visual Studio Code, however, we are going to actually use this IntelliJ for the first batch, which is Java. And the reason we're doing that is because it makes it easier to run our Java and compile our Java specifically, as opposed to like JavaScript and other things which are run more robustly. We'll talk a little bit about that in a minute. So I'm going to pause the recording and I'll come back once. So we've got the install running, and once the install is done, I'll continue the recording. So we're back, and our install is complete. Now we're going to run IntelliJ Edition, IntelliJ IDEA Community Edition. So just click Allow, and allow. It's asking me where to import my settings from, and this is just because I have other IntelliJ project programs installed on my computer and I use for other purposes. For example, WebStorm is like a web development one that I use a little bit for some web development techniques and things. But we've got the actual program starting, and this is just the startup screen. It looks like this. We're going to go to create a new project, and here's where what I was talking about, where it'll actually automatically offer to download the Java SDK for us. So first off is if I look at new project, I've got a bunch of different options. We're just going to take Java for now. I'm going to change location from IDEA projects to my projects folder. I'm going to select this folder, and then inside this folder I'm going to create, my project is going to be called, for now we're just going to call it Java Basics. And I will upload this code. I will upload the code and make it available to you. And you'll see over here, project will be created in project/Java Basics, which is perfect. We don't want to Git repository. Don't worry about what that is. You'll learn about that some other day. We're going to use IntelliJ as opposed to Maven or Gradle. Don't worry about those. And we're going to, hey, what's the Java development kit? Meaning, what version of Java do I want to work with? We're going to say download. And because I don't have any in my computer, we can actually download a specific one. So we can either do download OpenJDK 25, or I can do download JDK, and it gives me a complete list, which I'm going to cancel for now. I'm just going to let it download JDK 25 for me, which is the most recent up-to-date version. And yes, there are different versions of programming languages that include different features and little things like that. So here I've got a basic program, and if you look at it, you'll notice it looks very close to the program we wrote the other day. It is slightly, the program I wrote on the board the other day, it is a little bit less, and we'll talk a little bit about it in a moment. You'll also notice that I'm getting a bunch of these little red lines. Also, this is very small and hard to read. So I'm going to start by zooming in. I'm going to go to my settings, and we're going to go to appearance, and we're going to zoom to 150. There we go. It might be a little big, but hopefully it makes it clearer on the screen. And if it's too big, we'll just blame it on the fact that I'm old. So now that the JDK thing is finished installing, you'll notice now that I've got the IO, and all these different words are now in different colors. I've got this format and all this different stuff. I am going to delete all of it. So if you remember what we said when I said we run a program, and for Java, the code for the program needs to be inside something. So we're gonna go with void main. And now I'm gonna do. Excuse me. We're gonna do. Actually, we're gonna rewrite this as class driver. Class driver. And inside the class driver, we're gonna have public static void main. And then this is gonna be string args. And then in here we're gonna do system dot out dot print it dot print, and I'm gonna print hello. And now I'm gonna click the little play button, and I'm gonna run my driver.main. And you see how it printed out the word hello. Cool. We wrote a program. Isn't that amazing? We wrote a program, and the program got executed. Great. What does that actually mean? What does it actually do? How does it actually tie into anything? And what the hell's going on here? Right. So we are going to go through all of that. And then I want to start talking a little bit about, this is environment setup, and I'm going to start talking a little bit about data types also in this one. So I printed out the word hello. Right? How did I do it? We spoke about it last class. We spoke about how with Java I need a class, and then I need a function, and might not always need it, but it's best practice to have it. And then inside that function I can do a thing, and then whatever a function is basically a block of code that we can reference. So here we're saying, hey, start with this block of code, but then I can create another function, right? I can create some private function. Oops, I gotta type this correctly, but I can go over here and I can type the word. I can do private silly private static string, or even better, integer silly, and this will take in integer n, and I will explain what all of this does in a second, and this will return n times 3. So if we go back over here, and now what I'm going to do is, instead of doing this, I'm going to go print, then I'm going to go silly 5, and now I'm going to run this program. And if we've done everything correctly, it actually prints out the number 15. So that is a little bit complicated. I imagine that you guys are at a little bit of a loss. Don't worry too much about it. You can follow it slow. You can break it down. We're going to break it down piece by piece. And like I said, these videos, the goal is to explain a bunch of stuff in depth kind of quickly so that you can go back over it at your own pace, and you're not going over an hour and a half long video. So I'm going to try to keep this one to under 20 minutes. The install and the download stuff, that's not really something I can control. That's why this one's going to go a little bit longer. But usually I try to keep them to under 10 minutes. So what do I do? What are we doing here? We are going to talk a little bit about programming and how this stuff works. Specifically, we start by doing this bunch of code. Now this bunch of code calls silly, which is this other bunch of code. And that bunch of code needs an integer, and I will explain what an integer is in a minute. And it returns, means it gives back that integer, that number, times 3. So I give in the number 5, it gives me back 15. If I did the number 20, it would give me back the number 60. Now, let's take a step back. What is the point of programming, right? And I'm actually going to do, going to go over here for this. Hi, what's the point of programming? The whole point of programming is to there's a bunch of different rules, but basically it's, to compute, to manipulate data, right? Programming at its core is manipulating data. This is not the only thing, or this is not the only way to look at it, but it is a way I like to tend to look at it, especially early on in your programming career, because ultimately that's what we're doing. We're manipulating information, and based on the contents of that information, we'll change like how signals go to a device, right? For example, right now I'm recording through a camera that is sending the image live to two different screens, which is why I keep looking over there, because that's where the other screen is. And it's also showing me like what's on the screen that you don't see right now, so that I can really quickly push a button and fade back and forth. And I get to see what is on both of my screens at all times, and all that stuff is actually cool code shit that happens, right? But we got to start with the basics. And so for manipulating data, we've got to know the kind of data we're manipulating. If what we're doing with programming is we're organizing information, we have to know the kind of information we're organizing. And this is why one of the most fundamental things of programming is what are called data types. So there's a bunch of different kinds of data types, and there's some like really simple data types, and there's some more complex data types. What we call primitive data types are the most basic data types. And I'm sure that your other professor will have given you a long list of those kind data types, which are literally the types of data that we can have. But in general, a language like Java is really great to start with for this, because Java is what's called strongly typed. And now strongly typed means which it's no longer strongly typed. You actually can do a weakly typed version of Java, but we're going to stick to making it strongly typed. Now what Java does is it actually allows us to say I have some piece of information that I have to identify what kind of information that is, right? So for example, over here, I'm going to say I want, right? So for example, in my code over here, I have this, what's called a variable called n. What is a variable? A variable is a way to refer to something I don't know. So those of you who are familiar with the term from mathematics, and in general, a lot of computer science adopts from mathematics. In this particular case, the computer science term is a variable, which is taken directly from mathematics, which is I use some symbol, some like letter or number or word to represent a value that I don't know the value of, or a value that could be anything, right? So if we look at my code again, what's happening over here is I'm saying, hey, I need an integer. I need a number. An integer is a whole number. It is a kind of number. And I need an integer, we'll call it n, and I'm going to give you back an integer. So you give me an integer, I will return an integer. That's what this block of code does. This block of code is private and static. Don't worry about what those words mean. But it will give back an integer. Its name is silly, and it takes in an integer. So you give it a number, it'll give you back a number. What does it actually do? It takes the number and it multiplies it by 3. All those like numerical operations and things like that you've probably covered in your other class, and we're going to cover in your other class covering Java. We're going to cover those operations across multiple different languages, and a big part of this class is going to be looking at the different languages and how those operations compare across different languages, and how many different versatile ones there are core to the language. But for starters, we need to talk about the things that we're doing those operations to. So we've got, when I say operations, it's a very technical term to mean stuff you do with information. In this particular case, I've got the number that I'm working with, right? So I'm manipulating a number. What else can I manipulate? I can manipulate a string. A string is a series of letters, so that's a character. So I've got characters, which are letters. I've got strings, which are a series of letters. I've got a number, right, which is an integer. Now, an integer is a whole number. There are other kinds of numbers. Those are like doubles and floats, which are numbers with decimal places. So really quickly, we're going to actually type up some of these. So I'm going to type up string a equals hello, right? And this is an example of a string. Next, I'm going to go, then we're going to do char b equals a. So this is a character. This is a single individual character. The next thing we're going to do is we're going to have a integer, right? Which is another one we spoke about already, right? Integer c equals, and then we'll do 5. Right, so integer c is the number 5. Now all of these are just different kinds of data. I'm not storing them anywhere. I'm not doing anything with them. I'm storing them into the variable. I'm never actually using that variable. So A, B, and C are created, but they're never used yet, and that's fine. It doesn't really matter. But these are the different data types that exist. So I can also have a double, and I'm sure that you've already gotten or you will get a formal list of these from your other teacher. But a double would be, let's say, 1.5, right? So this is a number with a decimal place, and there's a couple of different kinds of numbers in Java and in a lot of programming languages that are strongly typed. We have different types of numbers. Now, what the difference in data types when it comes to like the difference between a double and a float is how the information is actually stored in the computer. Because what a computer does when it stores it is it will store the data potentially in a lot of depth, right? So it'll store the data. That data has to take up space somewhere. So all of our basic data types, all of our really simple data types are going to take up. Sorry, this should really be int instead of integer, and I believe double should just be double lowercase. Sorry about that. Yeah. So and string should be str, right? No. String. No. String has to be capital. All right. But the rest of them can be lowercase. Notice how the lowercase ones are purple, and this is because they are what's called primitive, which means they're more built into the language. There's a lot more complexity that goes into the theory behind that, but don't worry too much about it. Just know that that's a thing. And just keep that idea in the back of your mind. The big idea here, and the more important idea, is that we've got all these different data types. Now, we've got strings and characters are just, different flavors of the same thing. I've got ints and I've got doubles, and technically I've got a float, right? I can type float here, float f equals, 1.2, right? And that is also just a different kind. Whoops. Right. Sorry, I need to actually add the f to tell them that it's a float. And there's a bunch of stuff like this. But those are all just different kinds of numbers, and the only real difference is how they are stored on the machine. And this really does matter. There is a difference because technically every number only takes up a certain amount of space. So if it can only take up a certain amount of space, it can only go so high. After a certain point, you literally cannot store any more data in that particular slot, because let's say it only holds 5. It can only hold, let's say, 5-digit number, right? So if you have a 6-digit number, you're going to get what's called an overflow error, and the number becomes negative of that thing. There's a whole conversation to be had about that, and we'll talk a little bit about that. Because this is more a theory course, I will explain the theory of that stuff in depth in person. But I want to talk about the last data type we're going to deal with here, and that is a Boolean. Boolean, E equals true. And then we're going to have a second Boolean, G equals false. A Boolean is only ever true or false. We've spoken about binary, right? We've spoken a little bit about how computer code and things reference binary numbers and whatever that means, right? And it means that things are switched on and off, and so we keep track of on and off. And so a lot of the logic that we deal with is true and false, all the logic we deal with is formal logic. Formal logic is a field of mathematics and philosophy. It's an intermingling field of mathematics and philosophy, where you have formal structures that basically a statement is either true or false. We don't care about the details of the statement, and then we just do some cool, what basically looks like a form of math to logical statements. In this case, in computer science, we do this all the time. And that's what a Boolean is. A Boolean just keeps track of true and false. So over here we've got our true and false statements, and this is used with like if, and we'll see how these are used next week, but I want you to get this idea in your head that aside from the string and the character and the number, we've got a Boolean, and a Boolean is a really big deal in programming, even if it's something you've never really heard of before. Those are the fundamentals. Get IntelliJ Community installed, mess around a little bit, play with this, do some basic math, see what you can come up with on your own, and we will go into a lot more depth on the core of these ideas next week.